Right triangle trigonometry. What we're going to do in this video is look at this triangle and think about how the sides are labeled in relation to the given angle. And then we're going to define some functions based on the relationship between the angle and the ratios of the sides. So first, let's take a look at this triangle. We can see that it's a right triangle, and one of the angles is labeled t. Now, these sides are labeled in relation to this angle. Well, the hypotenuse is going to be the hypotenuse kind of no matter what, right? It is just across from the 90-degree angle. So that one is always the hypotenuse. But now let's see how we labeled this as opposite and adjacent. Well, if I am a little guy standing here at angle T, then the opposite side is like across from me, right? It's the farthest thing away. It's the opposite side. And then the adjacent side is going to be actually on the ray, right, that helps define this angle T. Adjacent means the next to, so it's the next one, whereas the opposite side is opposite or across from it. So now let's look at how we can define the following trig functions. And we're going to start with the sine, cosine, and tangent functions over here, because those are kind of the big three. So the following trigonometric functions can be defined by the relationship between the angle of interest, so some angle that we care about, and that is going to be, the angle of interest is going to be the input, okay, and the ratio of the two sides of the right triangle. So the ratio of the two sides, that value will be the output. Okay, so the input is an angle and the output is the value of a ratio. So let's look at these three functions. We call them sine, cosine, and tangent. And then what does it look like? Well, it's a little confusing because we don't have symbols like we do for, say, exponents or square roots and things like that. But we do have the name for the function, and that's going to tell me what the output of the function represents. So sine is the function's name, or sin. T is the input. That just means the angle is the input. And then the output is the value of the length of the opposite side over the hypotenuse side. Okay, let's look at cosine. The input is an angle, and then the output is the adjacent side to that angle over the hypotenuse. For tangent of t, the input is t, and then the output represents the ratio value of the opposite side length over the adjacent side length. Okay, that seems like a lot to memorize, and it is, but something that can help is called SOHCAHTOA. And you might have heard this before, but how does it help us remember these things? Well, it just kind of reminds us. Let's see, we're looking at, so for S-O-H, S is for the sine, O is for opposite, H is for hypotenuse. For C-A-H, C for cosine, A for adjacent, H for hypotenuse, and TOA, T for tangent, O for opposite, and A for adjacent. So SOHCAHTOA. So then now it seems like I've got these other three to memorize, but maybe we can just memorize them in relation to these other three. And we'll be working with these, all terms. So it's something that we'll be very familiar with, pretty quickly. So let's look at now cosecant, secant, and cotangent. So these three other functions. But what I like to do is think about them in relationship to these first three that we already looked at, sine, cosine, and tangent. So what I notice is that the sine, the S for sine, and the C for cosecant, and then there's a C for cosine, and then S for secant. So they have to kind of go with the opposite, right? The S and the C's go together is what I mean by that. And now if I compare sine and cosecant, sine, its output represents the opposite over hypotenuse value, where cosecant, it's hypotenuse over opposite. So these are just switched, or the reciprocal. Same with secant and cosine. Cosine is adjacent over hypotenuse, and secant is hypotenuse over adjacent. Tangent is opposite over adjacent. Cotant is opposite. Oops, I forgot to switch those. So this should be adjacent over opposite. There we go. Okay. So how can I write this kind of more formally and not just say, well, it looks like they're switched. And so what I can do is I can say cosecant of t is just the same as 1 over sine of t, because it's really 1 over opposite over hypotenuse would just flip those for me and give me the reciprocal hypotenuse over opposite. All right, let's keep going. you can probably see what's going to happen here. Secant of t is 1 over cosine of t, and cotan of t should be 1 over tan of t. Okay, so we call these reciprocal identities, and they're really important because then I can really just memorize SOHCAHTOA, and then these other three are just the reciprocals of those three. And then one other thing that's going to be really helpful, and we might as well just introduce it now because it's the kind of thing that just comes up all the time, is looking at tangent. So first I'm going to just start out with sine of t over cosine of t. And notice I don't just write sin over cos because this is a function and functions have to have inputs. So like if I just wrote the square root without anything inside, it would be meaningless. It's the same thing if I just wrote sin without some type of input. So here the input is just the angle t. Okay, if I do that, I know sine is just opposite over hypotenuse, and cosine is adjacent over hypotenuse. Now, if I go to simplify that, I see the hypotenuse just cancel out, and it just gives me opposite side over adjacent. Now, when I do that, I go, wait a minute, opposite over adjacent, that's just tan. So this is equal to tan of t. And so what I've established here is that sine of t over cosine t is always equal to tangent of t. And that's true for any angle, right? There's something special about this angle t that we're talking about. And this is called a quotient identity. And it's going to be really important, kind of as we study trigonometry. So it's just something that we kind of want to establish now so that we can use it later on.